Good morning. This is my video submission for the end semester examination. I am Manvendra, and this video will answer the fifth question, which states that there is a need to prove a certain identity of this kind. So, I'm sorry about this. This needs to be proven. So, starting from my left hand side, so LHS is equal to the Laplace transform of a certain real valued continuous differentiable function f prime. So definition states that the Laplace transform of any function can be written as this, right, wherein an integral exists for this. So this can be taken. So to prove the right hand side, I would use integration by parts. I would take this as my second function and this as my first function. First function. So by rule I can state something like this. Ft, I have integrated my second function before getting the limits here, so that should be taken into account. Okay, so this is true, becomes plus now. So this is how we define integration by parts. So now this looks a bit like my right hand side, which is like this. So this is the slightly difficult part. So S is by its nature positive. We're talking about positive shifts here, so the exponential part of the integrated function here will tend to 0 as this part tends to infinity. Now this function is smooth, or rather piecewise smooth for t greater than 0. That's a fact. So for every infinitesimal step in when you're trying to shift it with some variable, this function will be finite. So the overall value of this thing at its upper limit will become 0. So we will have something like this times 1, because this part becomes 1 if we put t is equal to 0 times f of 0f. So this is what we get. This function is looking a lot like transform of f, so I can write this. So just by changing, sort of re-engineering the expression, I can get something of this kind. Now this expression is equal to the right hand side, so we have been able to prove that LHS is equal to the RHS. Therefore the Laplace transform of f prime is to this. This actually is 0 plus, but let's not take that on, right? So this is the correct answer, and we have proven the identity given on top.